Hello everyone, I'm Rohit and you are watching today's session about building cost-effective multi-tenant Kubernetes for real-time AI processing. So what actually it means, I will just give a brief in some time. But to start with, who am I? So I'm Rohit. I'm creator of Create MVP. So Create MVP is nothing but a platform to give you requirements, implementation plan for AI tools to make like AI prototypes in a seconds. So other than that, so I'm also CNC ambassador. I'm marketing chair for CNCF. I'm founder of WLS service and other like organizing stuff I do. So yeah, definitely check it out if you have some time. So other than that, so let's go ahead and start with our today's topic. So which is about let's say you have actually built some multi-tenant Kubernetes environment, right? So how to make it optimized for real-time AI processing as AI workloads continue to grow exponentially. So do our infrastructure cost and complexity. So let's see how we can do it together, right? So let's begin by defining. So first of all, let's go ahead with this amazing, we can say, Kubernetes journey. So this is like 10th year of Kubernetes, right? So first year of Kubernetes and 10th year, it is still quite a journey. So what is actually multi-tenancy? So let's say in a multi-tenant environment, a single infrastructure instance such as your Kubernetes cluster is shared by multiple tenants. So each tenant could be a different team, department, or even an external customer. So they require their own isolated environment, and that's where Kubernetes comes in handy. So multi-tenancy improves resource efficiency, then reduce overhead, but it also introduces such challenges like secure isolation, fair resource sharing, and noise isolation between workloads. So this is kind of a diagram which I created recently. So you can see namespace isolation in Kubernetes. One of the most common approaches to implementing multi-tenancy is through namespace isolation. Each tenant gets their own Kubernetes namespace. So benefits of this method includes like simple to use, easy to set up and manage, then logical segregation of workloads and policies. However, it also has some limitations. Tenancy can still view each other's resources unless additional restrictions are in place, which is really complex, I would say, right? This is not ideal for regulated industries or third-party client scenarios, and so another like cons of it. So definitely, fortunately, there are like CNCF ecosystem offers several open source tools that can help solve these challenges. Like one of the challenge projects is like virtual cluster. So vCluster is nothing but it is a Kubernetes concept that enables isolated cluster to be run within a single physical Kubernetes cluster. So if you have tried vCluster, I would definitely recommend you try it. Like it helps to build like more secure, efficient, observable multi-tenant environment, and it is like it has like shared platform stack, so you can isolate everything. It can save you a lot of cost. So then there is this is funny thing, right? Using namespaces to partition your multi-tenant cluster is like different stack at over it. So, what are the challenges of like current real time AI processing? Is like you will see like in the real time AI workloads present unique challenges. On the left, we can have the resource demands. They require powerful CPUs and GPUs plus low latency networking. On the right hand, we see like how cost explode through constant GPU provisioning and over provisioning nodes. At maintaining strict latency requirement, fraud detection systems, and autonomous applications, this kind of a real world use cases can't tolerate delays, right? So, what can be solutions? Yeah, so our solution objectives can be prioritized as shown in this matrix. Node auto scaling provides high efficiency with relatively simple implementation. This is this is nothing but let's say your normal thing. Then GPU multiplexing offers even greater efficiency gains through with more complex implementation. Network segmentation gives you solid security fundamentals while multi-cloud deployment readiness provides flexibility but with limited efficiency impact. So I have like architecture diagram. So here you can check this circular diagram represents our comprehensive architectural blueprint. The six components work together to create a complete solution. We start with cluster architecture, defining the structure and distribution. Our tenant isolation model ensures secure environments for different teams. Cost optimization strategies reduce operational expenses. Then the real-time inferencing stack provides tools for processing your data with low latency. Observability gives insight into performance and cost, and security and compliance is there, right? Which is nothing but enforces your necessary safeguards throughout the system. So what can be cluster architecture decisions can be taken? So for our cluster architecture, we need to decide whether to use a single cluster with namespaces or multiple cluster for tenant isolation. For GPU workloads, I recommend integrating like NVIDIA GPU operator toolkit, then with device plugin, then DCGM exporter for metrics. What are these things? I recently gave a talk at KubeCon, so definitely check it out. I have given more gist about it. So for even better efficiency, consider time slice multi-instance GPU profiles, which allow you to partition GPUs across multiple workloads. If you are on managed Kubernetes like EKS, AKS, GKE, Civo cluster, all support GPU workloads well. But if you are self-hosting, K3s offers a lightweight option that works surprisingly well for inference workloads. So definitely check it out. Then I would like to show you this diagram first. So multi-instance versus multi-tenant. As shown in this diagram, you can see there are two main approaches to multi-tenancy. On the left, we see the multi-instance model where each tenant gets completely separate application and database. Then we have like on the right is the shared multi-tenant model where tenants share infrastructure with logical separation. So soft tenancy uses namespaces with RBAC controls and network policies. It's cost efficient but has moderate isolation. Hard tenancy uses virtual clusters or separate clusters, which I just showed you, offering stronger isolation at higher cost. So for internal teams, soft tenancy is usually sufficient. For external clients or regulated industries, hard tenancy provides security guarantees your need for different things. But it depends on your use cases. Like sometimes you need to like provide cost optimization. Then I would definitely recommend you to do like GPU sharing or vCluster architecture, which saves you like 20%, around 80% of cost. They claims then there is it's like it completely depends on your own company architecture. AWS has nice blocks around it. Red Hat has nice blocks around it. So one of the thing which is like GPU sharing, which talked about, right? So let's say then you want to save your money, right? So GPU optimization, GPUs are really expensive and often underutilized. So NVIDIA's multi-instance GPU technology lets you partition a single GPU into up to like around 7 8 isolated instances, each with different dedicated compute and memory. So for workloads that don't need the full capabilities, this is perfect. I would recommend. Then time slice GPUs work differently. They allocate full GPU access, but in time windows ideal for a non-continuous inferencing task. Then you should also implement custom scheduling with tools like KubeSlice or Volcano, which is CNCF across projects. You will check out to batch low priority inference jobs, maximizing GPU utilization during off-peak periods. So these are the few things. Then you can also do like let's say carpenter on AWS or GKE autopilot, which can help you bin packing capabilities to maximize resource efficiency. Then let's say the jobs which are not non-critical, let's say, so we can serve them on spot on or preemptible instances, which can be 70 to 90% cheaper. So implement some fallback mechanism. You can use notations and tolerants for workloads that can actually handle your interruptions. You can also carefully oversubscribe CPU and memory. So these are the few things. Then talking about our real-time inferencing stack, you will need a model server like, let's say, NVIDIA's Triton Inference Server, which offers optimized inferencing across framework. Let me show you one of the diagram. So we will come to this, but yeah, you can do different themes for real-time data. Typically comes through streaming platforms like Kafka or and Jetstream work well, kind of a thing. Then you can also use SCADA, which can use for the auto scaling, auto scale based uh, event queue length for like event driven workloads. Then these are the few things you can do. Then talking about one of the thing I would like to recommend is like try out different CNCF projects like you can check out the Kafka or Red Panda, which is let's talk about real time AI architecture stack which we talking about. So let me check. Yeah, we have it here. So Kafka or Red Panda for like real-time event ingestion, then Triton Inference Server or Serve, which is really popular project during KubeCon to host models. Then Envoy or Istio as the API gateway, then KEDA to scale based on external metrics, Qdrant or Viviet for vector similarity search. This can help you like creating Kubernetes ecosystem which provides responsiveness, scalability, and observability. You can use Prometheus Grafana for metrics, Fluentweight for logging, Falco for runtime security, then OPA, which is your OPA for like, let's say, policy enforcement, and Cilium for network segmentation with eBPF. So that's what is given here. Then there's also one of the popular case study which I recently came across. Like there's a fintech company which deploying multi-tenant inference pipeline across their different regions. So they use vCluster for hard isolations, and they use GPUs for cost sharing, then Cube cost for tenant level cost tracking. So they reduce cost by 38% while maintaining like SLA adherence, right? So definitely, I would recommend you to follow these guidelines whenever you are coming across uh, making this real-time AI processing by like to build your cost-effective kind of thing, clusters maintenance and all. So this is one of the example like real-time fraud detection process, which I actually discussed already. But yeah, definitely. So let me know if you have any questions. And these are the some CNCF projects which can help you a lot. I will share the slides to you. So definitely check the slides. And if you have any questions, you can write down in a comment. So yeah, let me know if you have any questions. I would love to answer them. And if you want to connect, these are my socials: LinkedIn, Twitter, GitHub, and definitely check out the Create MVP, which is really nice project. And then the kubectl MCP server, which I recently created for like chatting with Kubernetes cluster, so you don't have to write the commands manually. So yeah, thank you.